Okay, this is page 195. Be sure you have something to write with. And are on 195. I gave you an extra sheet of paper as well because I want you to show steps to some of these problems, especially down here where we don't have a ton of room. What? Yeah, did you give me back your pencil for that night? All right, then it would be here, mine. Or maybe we didn't make you one. There it is. Perfect. I need to make you one. Yep, quickly. Guys. All right. Additive inverse. Remember, that's a big fancy word for opposite. So the opposite of negative 48 is what? Yep, we would just say 48. The opposite of 27 is negative 27. So this is the same thing, except sometimes we have decimal numbers, sometimes we have fraction numbers. 195. Yes, page 195. It was like 195. All right. So what's the opposite of negative 1/2? One half. So whatever would make it 0, if we added it to it, that is this. That's what additive inverse means. So if we said negative 1/2 plus 1/2, it would be 0. So we would just write 1/2 here. So if you don't have that yet, make sure you have it now, right? Okay. What's the opposite of 2500? Negative 2500. So that's what you should be writing for number 2. Perfect. That's all you had to do. What's the opposite of 9/10? Negative 9/10. And how about the opposite of negative 4/10? Positive 4/10. Excellent. All right. Any questions on 1 through 4? No, next one. Okay, Quinn earned $24.50 dog sitting and $12.70 for recycling cans. Find the total amount he earned and describe a situation in which Quinn ends the week with $0. So what did you do? How did you solve number 5? Why not? So we're adding these. Oh, it's $1 only defined. We're not amused. At this point, it's harassment because we've asked you to stop. Over and over again, you continue to do it. So you can add them up, line up your decimals, bring down your decimal. 37 2/10 or $37.20. So what would the situation be where she ends with $0? She spends, or he, I guess it is. So Quinn spends $37.20 at the store. How's that? All right, number 6. Rachel spent $3.89 on a magazine and $4.86 on a smoothie. So she's spending that. She's actually losing it. So we would have negative $3.89 plus negative $4.86. No, it does not become a positive. Good. So when our signs are the same, we find the sum. So we are adding these. Line up your decimal. 9 and 6. Carry your 1. 8 and 8. Plus 1 more. Bring down your decimal. So she spends $8.75. So that's negative. How would we describe a time that she ends the day with $0? She earned that doing what? Chores. She did chores and earned $8.75. Her brother gave her a gift of $8.75 that he found when he was cleaning his room. I don't know. But in order to be at 0, she has to gain this because she's losing it when she's spending it. In order for Quinn to be at 0, he has to lose this. So this essentially has to be negative, the opposite of it, because he earned that. Dog sitting in with cans, right? Questions in understanding what the additive inverse means. The additive inverse is what is combined with it to make 0. So this is how we would use the additive inverse in real life situations. Fair? Okay, now this is the part that we have to break down and it gets pretty tricky. So this is why I gave you a piece of lined paper. So I'm going to start just by rewriting number 7. So number 7 is 3. I'm going to write 3 so that it splits my line right here. I'm going to put the 5 on top of my line because that's my numerator. And the 6 on the bottom, the line below. Plus, and then we have in parentheses, negative 1 and 1/6. So it's really important with math that you stay really organized, right? And you line things up. So in this case, since you already had similar denominators, did you line them up vertically or did you change into improper fractions? So did you line them up vertically or did you change them to improper fractions? What'd you do? Did you change them to improper fractions or not is the question. No. So you lined them up vertically. So if I said 3 and 5/6 minus 1 and 1/6, is that the same thing? Is adding a negative the same thing as subtracting it? Yes. Is that fair? Can we do that?
Yeah.
All right. Now, remember, I still have to start from the right and work my way left. So I have this is essentially the less than 1, not left. It's the less than 1 place value. And this is your 1's place value. So what is 5/6 minus 1/6? 4/6. Because we have like fractions, we can just take the numerators. 5 minus 1 is 4. The denominator stays the same. Now, they wanted us to write it in simplest form. Is this fraction in simplest form?
No, totally perfect.
Good. They both have a common factor of what? Would you divide them both by? 2. Whatever I do to the top, I have to do to the bottom. What's 4 divided by 2? 2. And what is 6 divided by 2? Now, don't forget this part, right? What is 3 minus 1? 2. Does that work? Is that what you got for number 7? Close to that. Close does not count in math. Close is a very exact. Close. Close is not an exact thing. Math is a very exact thing. Right? Question. Sure. Make sure you have lots of evidence to go with you. All right. Number 8. So if you want, you can put your answer here. Or you can keep the sheet in there. Number 8. Negative 13 1/4. Negative 13 1/4. Plus 4 3/4. All right, so here's my same question. Did you change to improper fractions or no? No. No? Okay. So our signs are the same or different? Different. If our signs are different, we have to find the difference. So we're going to subtract. Big minus little, right? So 13 1/4 minus 4 3/4. Can I take 3/4 from 1/4? No. No. So I have to borrow. So if I borrow from the 3, it becomes a 2. How would I write 1/2 as a fraction over 4? Fraction out of 4, yeah. How many pieces? Good. I would have 4 over 4. So if I borrowed this 1 becomes over here. So now how many parts out of 4 do I have? What's 1 plus 4? 5. So now this is 5/4 minus 3/4. Can I do that? Yes. I can say 5/4 minus 3/4. What's 5 minus 3? 2. And our denominator still stays the same. Is that simplified? No. What's 2/4 equal to? 1/2. Now I have to say 12 minus 4. What's 8? Is my answer 8.5? No, why not? This says 8 1/2. But is this my final answer, Ethan? Yeah. No, it's not. Let's look back to our starting problem. What do you notice? Why did we subtract? Oh, it's negative. Our signs were different, right? So it has to have the same sign as our bigger absolute value number. So our answer is actually negative 8 1/2. That's what you said, yeah. All right. Questions about number 8? Does that help you walk you through it? If you're just sitting there staring at me, you're not going to learn this. I can't help you if you're just sitting there staring at me, or if you've got your head down not doing anything. You have to actually do math to learn math. We learn math by doing math. All right, number 9, let's walk it through. Negative 2/3. Plus 2 3/8. Is that what it is? 2 3/8. Do you want to change it to improper? Is that what you're saying? No. They are different, so we need to change them to like denominators. You're right. Oh my gosh. How are we going to change them to like denominators? Multiply. But I think my next. Yes, we could multiply them by each other. So if we multiplied the 3 by the 8, we would get what? 24. Remember, it's still negative. And whatever we did to the bottom of the fraction, we have to do to the top of the fraction. So what's 2 times 8? 16. We're finding common fractions right now. So we're writing equivalent fractions. Negative 2/3 is the same as negative 16/24. Now we need to do the same thing, but with the 3/8. So I'm going to keep the 2 the same, because 2 times 1 is just 2. And we're really just multiplying this by 1, right? 8 divided by 8 is 1. Whatever. If we do the same thing to the top and the bottom, it's the same as multiplying by 1. So how do I get my 8 to be 24? What do I have to multiply it by? By 3. So if I multiply my 8 by 3, I have to multiply my 3 by 3. Good. Whatever I do to the bottom, I have to do to the top. So what's 3 times 3? 9. All right. Now I have like fractions, so I can try and deal. But my signs are different, which means I'm going to subtract. I'm going to find the difference, which means to subtract. So I'm taking big minus little. Which of these numbers is bigger? It's the 2 and 9/24, right? So it's really 2 and 9/24 minus 16/24. Can I take 16/24 from 9/24? No. So I have to borrow from the ones place. So that 2 becomes a 1. And how many parts out of 24 would be a whole? 24. So we're adding 24 out of 24. We're taking 1 from here and adding it to the fraction. So what's 9 plus 24? 10 plus 24 would be 34. So 1 less than, yes. So 33/24 is the same as those things added together. Now, can I take 16 from 33? Yes. So some of you, like me, might have to see this written down. Right? We're subtracting our numerators, our top numbers. 33 minus 16. Can I take 6 from 3? No, I'm borrowing from this 3. It becomes a 2 to make my 1's 3 a 13. What's 13 minus 6? 7, and 2 minus 1 is 1. Now that is not just 17, it's 17 out of what? Excellent. Because that was just my numerator. I still had to keep my denominator the same, because I was really saying 33/24 minus 16/24. I just had to break it down a little bit. Now, in my ones place, I have 1 minus nothing. So I simply have a 1. Is that simplified? It is. 17, another 17 would be 34, but not 24. And 17 is prime. Its only factors are 1 in itself. So this is it. Good question. Does it have to be negative? My signs are different, so we found the difference. But we said that this one was bigger, and since this one is positive, our answer is going to stay positive. If it's positive, if our bigger number is positive, our answer has to be positive. If our bigger number is negative and we're adding, or yes, it's going to be negative. All right, 7, 8, and 9. Do we feel a little better about some of these? So you need lots of work on equivalent fractions. You need lots of work on finding like fractions. You need lots of work on adding and subtracting mixed numbers. Is that what you're saying? Okay.
So you know how the beginning of everyone says go back to 12?
Uh-huh.
This class is going back.
That's good.
No, it's
All right. So let's try and get through 3 more. Number 10. Not 3 more, 3 more. 2.5. Ethan, I need you to stay with me, please. Plus negative 1/3. Did any of you change these to improper? No? So we want to keep them as mixed numbers? So we're looking at our denominators. What is the least common multiple of 2 and 3? Not factors, multiples. So that's like counting by 2, 2, 4, 6, or counting by 3, 3, 6, 9. So they have 6 as their least in common. So we're writing equivalent fractions out of 6. Very good. Our 2 is just coming over here. What do we multiply the 2 by to get 6? 3. So whatever we multiply that by, we have to multiply the top by. It's going to be 3. Is 3 half of 6? So does it make sense that 1/2 and 3/6 are equivalent? What do we multiply the 3 by to get to be 6? 2. What's 1 times 2? 2. All right. I think it's easier to see these vertically. We have 2 and 3/6. If we're adding a negative, what's that the same as? Subtracting. Or you can think our signs are different. I'm finding the difference. Big minus little. If I have 3 of something and I take 2 of that something away, how many of that something do I have left? 1 of those somethings, and it was out of 6. So 2 minus nothing is simply 2. Now just double check, is my bigger absolute value positive? Yes, so I'm keeping it positive. That one was probably our easiest one, I feel. All right, number 11. Here we go. We're going to have to figure out, do you want to change these into decimals or into fractions? Well, right away, is 1/4, is that an easy decimal? Yes, it should be, right? What's 1/4? How many pennies? 25. So as a decimal, we call it what? 25 what?
25
hundredths. Good. So if we have -3 and 7/10, and we're adding 1/4, is that what we're doing? Our signs are different, so we're finding the difference. So we're going to say big minus little. What's our bigger one? 3 and 7/10 or 1/4? 3 and 7/10, right? And we just said that 1/4 could be written as change. So we would write 25 cents like this, 25 hundredths. Remember, we said we're finding the difference because our signs were different, and that means to subtract. Can I just bring down this 5? No, what is actually in this place right here? A 0. So I have to borrow from the 7. It becomes a 6. The 7 becomes a 6. The 0 does become a 10. What's 10 minus 5? And 6 minus 2. Bring down your decimal. What's 3 minus 0? Whew, all right, so 3. Is this my final answer? No. My bigger number was what? Negative. So my answer is negative. Now, you should also be able to give this answer as a mixed number. So say this decimal, -3 and 45 hundredths. Good. We say the number after the decimal and we say what the last place value is. So -3 and 45 hundredths. So let's write it as we say it. -3 and 45. If we say 45 first, that goes on the top. Hundredths mean what is my denominator? 100. Now, the only thing I would have to do, Ethan, Lucas, Brooklyn, would be to simplify. Simplify. So what could I divide both 45 and 100 by? They end in a 5 and 0. We know they're divisible by 5, not 2. They're not even. 100 is even, but 5 is not. All right, so if I divide here by 5, I have -3. 5 times what is 45? 9. And 5 times what is 100? 20. -3 and 9/20. So either one of those answers would be correct for number 11. The last one we're going to do together, the last two, 13 and 14 rather, are going to be expected for you to do on your own, is number 12. Number 12. First of all, I'm going to turn my paper over. I don't know about you, but I don't want to try and squeeze it in there. So 12 is 1/3 plus 4.1. How do I say 4.1 properly? Not 4 and 1/10. So this is 1/3 plus 4 and 1/10. Think top, bottom. 1/10. What goes on the top of my fraction? 4 and 1/10. What goes on the top of my fraction? 1/10. Now the reason we can't change this to both to decimals is because what's special about 1/3? Do you remember? We have two types of decimals. We have terminating and repeating. Nope, terminating means it ends. Repeating means we have that number over and over again. So if you put 1 divided by 3 in your calculator, it would say 0.33333333333, right? So we have to change the decimal to a fraction. Now we need a common denominator. What's common between 3 and 10? 30. So we need something over 30 plus 4 and something over 30. 3 times what is 30, Tanner? If we multiply the 3 by 10, what do we have to multiply the top by? 10. All right, what's 1 times 10?
1 times 10 is 10.
All right, so what do I multiply the 10 by to get 30? 3. So if I multiply the bottom by 3, I also have to multiply the top by 3. What's 1 times 3? 3. So now you can set it the other way if you want to. 10/30ths plus 4 and 3/30ths. So if I have 10 of something and add it to 3 more of something, I have a total of 13 of that same something, which was 30 parts. And I bring down my 4. That's it. All right, so use the rest of this time to try 13 and 14 on your own if you haven't already. Try 13 and 14. Use this extra space. You've got enough time. You should be able to try those things.